Hello, welcome. On behalf of All India Oracle Users Group, a very warm welcome to AIoT Weekly Webinar Series. Before I introduce today's speaker, I think most of you know about All India Oracle Users Group. It's a platform where you can share, gain knowledge. And important thing is networking with fellow Oracle members. Currently, we don't have face-to-face events. It's a best platform to network is Twitter, right? So as you know, we are running the theme-based events. This month is really special for many of us, Maximum Availability Architecture Online Summit. The summit is serious. The summit consists of 9 events. We had one event on Wednesday with Marcus and Anil, and this is the second session. It is essential to attend all the events and ask right questions closer to the topic. And I need to really thank Anil and Marcus putting this together. And they are big supporter of community, especially AIoT. So please ask all your burning questions. Please try to keep your questions closer to the topic so that speaker can answer to this particular topic. And please ask all your questions in the Q&A bottom of your screen. And if you need any general questions, you can ask in the chat. Continue your conversation using Twitter. I think this is very important. I don't know how many times I told you that, more than 1,000 times now. I don't know when this COVID is going to end. I think we are in wave 3 now. It's important to build your network using virtual platforms like Twitter or LinkedIn, and that's going to really going to help us in terms of finding jobs, in terms of connecting with the right experts. So use those channels. And we'll upload the presentation material as well as recording. Especially recording is initially released to all the AIoT members, then later we'll publish to the public. And also, it's important since we are all volunteers, we don't have time to respond to all your emails. It's better to connect in Telegram, and it's a friendly chat. Not only that, we have more than 4,000 people in this group. Please ask your all burning questions. That is also another way of asking questions. And I think one important thing we are asking is, if you have a very good question, please put it in a Twitter and tag to Oracle Rack PMs, and so that this will be really benefit for other global community also, right? So with that, you can see we have expert joining from Redwood City. That's why we put this Redwood here in this picture. We have Ian Cookson. He is a product manager for Oracle Clusterware and application continuity. Application continuity is very important. So let's understand from Ian. If you don't know Ian, a small introduction here. Ian has been working with Oracle since the late 80s, having started consulting with Oracle version 5.0, SQL Forms, Pro-C, SQL Reporter. He worked as a consultant at Oracle and HP for more than 20 years, focusing on advanced features, performance for 100+ different companies in diverse business areas. Ian is a product manager, as I mentioned, for Oracle Clusterware and application continuity. So huge welcome. It's early morning for them. Not only Ian, we also have our experts like Anil Nair as well as Nancy joining. And please post all your burning questions. They're going to answer in typing. Also, Ian is going to pick his really good questions at the end and answer your all your questions. So with that, huge welcome to all 3 speakers, and importantly, Ian Cookson. And please go ahead and share your screen now. Yeah, thank you.
Okay, hold on a minute. Share my screen. Sorry. Oh, there it is.
Maybe show your face to our community for initially.
Yes,
I will connect virtually.
Okay, there we go. A little challenge on the connecting and sharing first thing this morning. Good evening, everybody. Good morning for those helping me out here. My name, as you just heard, is Ian Cookson. I'm very happy to be here to talk about application continuity. And I'm not going to keep the video on long because we want you to focus not on me, but on the material I'm presenting. But welcome, and please ask whatever questions come to mind in the Q&A as Sai mentioned, and let's get started. We've got a lot of material to cover. I'm trying to keep this technical as possible, and there's a lot of material, so I'm going to rush fairly quickly, anticipating that you can ask questions, of course, and that you will see the recording, so you can pause and just consider what I'm saying. So we're talking about application continuity in terms of bridging the gap. And let's just talk about exactly what that means. What gap are we talking about, and so forth, and then we'll get into the meat of this. First of all, application continuity hides interruptions. That's what its job is. Okay, and we're hiding from the point of view of the user. So the users do not. The intent here is that the users will not see interruptions. We're talking about MAA. We build on top of that. And this is the gap we're filling, the gap between what the MAA provides, the base architectural blueprints, the continuity and the accessibility of all the database or data tier, whether it's in a rack database and or you're running against your or standby or secondary site. That MAA best practices, those blueprints are aimed at providing access or continuous access to the database. So the database itself is always going to be available for you to connect to. But what happens when there's interruptions to those connections and so forth? And yes, there's lots of different ways for the database to be maintained and keep operating. In other words, operating the capability to connect to that database. If one instance or one node goes down in the rack cluster, there's 2 or 3 others available all the time. Hence the maximum availability architecture. But what happens when there are interruptions to the connections to the database, whether it's for planned maintenance or outages, outright failures, and so forth? Well, the problem there is, of course, well, the users can reconnect. That's great, but they've lost all the work they've done. They've received all these errors they have to deal with. And that's what we're trying to hide. We're trying to make it so that the users never see these events at the database level, and their applications don't see it either. No error messages, nothing. They just continue on without any interruptions. And no code changes to do this. Okay, it sounds like too good to be true, but it's actually the case. Okay. How do we get through this? Well, some of the things we anticipate we need first is, well, a well-behaved application. And, that's really difficult to define in many ways. But if you're following the best coding practices for your application, then you're good. You're returning connections to the pool and so forth. You're cleaning up your sessions as you end them and so forth. These are all important. Now, we've introduced a new configuration for application continuity. We call TAC, or transparent application continuity, that takes into account those applications that are not necessarily so well behaved or were coded long before a lot of these expected standards were considered. So we moderate that to some degree, but we still act best with a well-behaved application. We have to enable the client stack. Now, this does not mean we go in and change your code. We just change configurations. And we'll talk briefly about each of these pieces as we go through. Database has to be configured. Yes, once and done. Very simple. And we'll talk a bit more about that. Primarily, it's just creating database services. And then we want to make sure that the SLAs are being met and so forth. This is critical, obviously, for everybody. But this is a way of gauging that we've done everything right. And if we're still meeting the SLAs, then theoretically, the users are not being impacted. That's the expectation. Okay. We've gone through a lot of this already. We need services. It requires them. We're going to introduce a connect string that everyone should be using regardless. Okay. changing it in your tnsnames.aura files or wherever you've got it. And hopefully in a central location, not spread throughout everywhere. Return connection to the pool, I've mentioned this, so on and so forth. There's some excluded features that are difficult to deal with. XA, no, we do not support XA. That would be breaking all the rules because effectively we're replaying transactions. And we can play one leg of an XA two-phase commit transaction, but we cannot replay the other because it's in some other data source. Hence, we will not touch XA transactions. Drain them, but we will not replay them. New concept. This is critical to everyone's understanding. It was introduced with 12C, 12.1, and as part of the Java standard, the JDK 9. I think we're up to the long-term JDK available now is 11. It supersedes 9, of course. We prefer everyone to be on that standard. Okay. As I mentioned, we've introduced transparent application continuity as well. What we're talking about here are database requests, the concept of a unit of work delineated by request boundaries. And in the example you're seeing here, this is from explicit boundaries generated by the connection pool, the Oracle connection pool. When you release a connection, obviously you label that as the begin request, or the pool does for you. You do all your work, which are SQL statements, PL SQL, whatever. You roll these out and send them off to the database. They get processed. At some point, you either commit or just close your cursors and close the connection. In other words, return the connection to the pool. That signifies the end of the request. Okay. It doesn't matter what calls you've done in between. That's the end of the request, and explicitly stated by the connection pool. Explicit in this case is very good because it's your application knows exactly, or the user knows the unit of work. They know what they're doing, well, we hope, and they've specified this is the work I want done. I'm done with my work, so let's just end this request. You should only have one commit per request. That's kind of an obvious point, but not always understood or accepted. Now, the alternative here is if you've introduced transparent application continuity, the configuration for it, then that enables the database to implicitly mark sessions for database, the begin and end request for connections and database requests. The reason we do that is because not every application out there can use an Oracle pool. So now we have the capability built into the database to differentiate when a request starts and when it ends based on state changes within that session. State changes most likely are something like, well, I'm opening a cursor. Well, to the database that says, hey, somebody's starting a new request. Okay, so that is an obvious one. Commit or ending or closing cursors probably signifies the end of that request, and so on and so forth. Okay, so while that's very functional, works very nicely, obviously it's not quite as good as explicit boundaries depicted by the application or the connection pool, but it works, and we use these requests throughout the work we're going to be doing, whether we're draining, workload draining for planned maintenance, load balancing is an ongoing process. We balance at request boundaries, okay? Because the balancing act actually moves connections around or whatever else, redirects connections, and we want to do so when we start, before we start a request rather than mid-request. Let's carry on. Building blocks. How do we get this to work? Okay, this is very simple, in fact. And it's amazing just how few customers are actually doing this or have heard of some of these concepts. So I suspect that's not the case for you, but let's go through them anyway. Okay, we start off with MAA. You have to have this. Okay, this is MAA week. Hey, this is the way we look at it. That continuity is up in the top right. Okay, what is missing a bit here is the coverage the application continuity works with. We work in terms of the hiding outages or interruptions. We work in terms of rack rolling. Okay, so failovers between rack cluster or rack instances or rack nodes. Interruptions on the public network even for accessing a particular node. Okay. We also work in terms of whether that's planned or unplanned. Okay, so outages. We also work across roles transitions from the production to the replicated site, the primary to the secondary, whichever you like to call it. Okay, during that role transition, they can be this can be fully automated. Okay, and we'll show you how that happens. Very straightforward, but all the same, this is the area where you start having to look very closely at your SLAs and timeouts. Okay, and positioning wise, we introduced that the concept of or use of application continuity at the silver level, because as soon as you start introducing some level of rack functionality, that's when app continuity plays a role, because we're really focusing on your mission critical databases, your mission critical applications, and they're kind of synonymous with rack. Okay, high availability. Obviously, we work in the gold and the platinum areas. It must be active data guard, not data guard, has to be active data guard. So, not going to dwell too much on this. Everybody understands rack these days. You saw the presentation by Marcus on Wednesday, dwelling very heavily on this and MAA in general. Okay, and you want to set the active data guard correctly. We want fast sync, no affirm. Okay, if you're using local active data guard, far sync helps remove some of the dependencies on network and latency and latency issues. But effectively, with the data guard observer, the broker, you're going to see that we can provide coverage, protection for your application to hide the role transition automatically, transparently. Now, there's going to obviously, it takes time, and that time is still going to be noticed. So you're going to see a brownout for your application, but you will not see errors. You will not see failures. Anything started as work on site A prior to the role transition will be replayed on site B, and the world will carry on. Okay, if you want to, okay, go. Next, services. Database services are essential. You cannot do any of this without them. They're a method built in since Oracle 10.2 to provide location transparency, so that users and the applications do not need to know where they are connecting on what physical database. They just know they have to be on this database, but it could be anywhere. It could be any instance of that. And we provide a service, and we can fail the service or the connections over so that they can work elsewhere. Okay. We recommend at least 2, but you'll have more. You create these services independently of the default services that are provided by the rack database. An OLTP service kind of makes sense in a batch service. You may have one for this application and one for that application, or you may have a service for this OLTP component of this application and one for the batch or reporting processes. It's up to you. The Oracle databases support a huge number of services, configurations. Obviously, we want some sanity applied to that, but yes, hundreds, that's not a problem. Carry on with it. Okay. Connection strings, I mentioned this already. No matter what you're doing, use the right connection string. And this is the example we provide for everybody. We use it against our cloud. This is the one we use internally and recommend for everybody. Notice a single description with multiple address lists. Each address list is for a primary and as many secondaries or standbys as you may have. Okay. Load balancing so that you can load balance across the scans and so forth. You do not need to keep going back to the DNS. Okay. And you notice you would put in there the scan hosts or addresses and so forth. Okay. Service name, well, I've been talking about it services, but that's where it goes. Okay, put the service name in there that you're going to be used. Okay, one description, one alias for this particular service name. And then you don't need to worry whether the service is running on the primary or the secondary. The automatic retries, those are for the role transition. They cover the role transition period. And if you look at that, that's retry count of 50, retry delay of 3. So that's 153 seconds. So 2.5 minutes. The anticipation there then is that your role transition is going to take less time than that. What we're using these retry counts and retry delays for is for your application as it works through the net layer to keep trying to connect for 50 times over with a 3-second delay. And once the service, Gold Cloud in this case, comes up again on the newly christened primary, following the role transition, it will connect automatically and then carry on. That's the point. And it hides all these things, means you do not need to be restarting app servers or anything like that to pick up new connect strings. Okay, so let's carry on into use cases. And the primary use case that we see is maintenance, patching. We're doing it all the time. Oracle advocates quarterly patches. Well, likely you're doing it even more frequently than that. Okay, because it's not just the Oracle database, it's the operating system and so on and so forth. Firmware that has to be patched and upgraded and so forth. So this is where we're seeing the most use of this, and in fact, the most impactful use. Okay, impactful in good terms. We want to prevent when the service is available and so forth. And we also want to be able to allow you to, or provide the capability for you to schedule your maintenance in hours that make sense. So you don't have to do it at 3 o'clock in the morning on a Sunday or whatever time is in it. Someone's cooked up in the past. You no longer need to be planning scheduled outages. That just doesn't happen anymore. You don't need to do that. The beauties of rack is the availability of the cluster nodes and rack rolling patching and so forth, and the applying of RUs and so on. And that whole concept is supported and very much promoted with the use of application continuity. In fact, in those scenarios, application continuity is just enhancing the capabilities of the rack database that are already there, that you could have been using since 10.2. Okay, we drain, or we migrate the work before the maintenance takes place. Okay. It's a big sinkhole there, it's a big drain. And the whole idea is work that has been sent already via a service to a particular instance must now be drained before you do the maintenance work on that node or that database, home and so forth. And so what we want to do is we drain the work from a particular instance while new work is being redirected elsewhere in the rack cluster. Hence availability. It's the HA, the norm, you might say, for rack databases. User work is automatically drained away. New connections are mailed elsewhere, and so on and so forth. Pretty straightforward, you might say. How do we make this work? Well, the best solution is to use fan, draining, and rebalance. Best solution here, okay? This all works best on the expectation of an Oracle pool. Oracle pools are universal connection pool for Java. ODP, the OCI session pool. ODP.NET has its own managed pool concept. Tuxedo does, and then WebLogic, of course, with Active Grid Link. Those are that's the primary solution that we see, and this is what we used primarily in 12.1, and we continue to use today. There are some new changes there, and we'll get to that in a moment in that concept. But in these cases, you can configure third-party app servers for Java, at least, to use UCP as well. IBM is a huge proponent of UCP, and they recommend using UCP whenever they have a WebSphere customer connecting to an Oracle database. Done. And they've documented this very closely. Same goes for Liberty, Apache Tomcat. Well, it's out there. It's used a huge amount. And yes, this is very simple to configure UCP for that. Okay. And Spring Boot, you're seeing more and more as the application framework. And there again, UCP slots in very easily with that. The one exception here that you're not seeing is JBoss. And that's because they've just introduced their own capability to support native connection or native application continuity. In other words, request boundaries within the JBoss native pool. Okay, and if you want more information about that, contact me offline. We'll talk to you some more, or we'll have another session. Who knows about specifically that. This is revolutionary in this part of the business. Now, for the DBAs, they just need to know they've got to create the database services. We've talked about that already, but they also need to be able to manage the process of initiating the drain and so forth, and managing patching. And to initiate that, they use an srvctl command. They either relocate or stop that particular service. You'd use relocate when you're working with a singleton. If the service only runs on one node at a time, when you want to do patching on that particular node, then you relocate the service elsewhere. And what that means is we're going to start the service elsewhere in the cluster. Potentially the DBAs mentioned where that would like to be. Otherwise, it'll follow the preferred and available rules. So it will start on another node. At that point, as soon as it comes up and starts, enables itself to receive new connections, in other words, it's registered, then we will shut down the service locally. So at no point will there ever be a situation where the users cannot connect to the rack database. So they will connect to where the service is now running, leaving the current instance to drain. So immediately new work is redirected, as I mentioned there, right? And then the work currently on that instance drains automatically for you. In other words, we just process it through to the end of the request. Remember, we're talking about database requests. We drain that request all the way through to the end, and then pass the results back to the users. We're done. Okay, and they can make a new connection to start a new request elsewhere. But so what part does application continuity play in this? Well, what happens if they do not drain? Notice there's a drain timeout on that relocate or stop service. And you might say, well, 10 minutes, 20 minutes, whatever. In our cloud, we default to 10 minutes. You shouldn't go short on this. There's no need to be. I really want to emphasize this. Be patient with this. Be all-encompassing. I'm not saying 24 hours, but there's no reason why 30 minutes doesn't work. Because what is going to happen here is we're going to drain and drain and drain until for 30 minutes. If everything drains within 10 minutes, then we just shut, the instance is automatically shut down at 10 minutes. We don't wait the 30 minutes. Hence, what are you losing by having the drain timeout longer? The other point here is, remember, we've always got a position where point at which new users or new connections database requests can be made to somewhere else in the cluster. That's the point of having a rack cluster. In which case, why do we have to make that drain short? Okay, so let's just make sure the drain is long and possibly longer than necessary. There's no issue there. It does extend the patching process, you might say, because it's going to drain for 30 minutes. Okay, you've got to wait 30 minutes before you start patching, but that's fine for most people. Okay, so we've done that. Now, what happens if your database request is not fully drained for whatever reason during that drain timeout? Well, at the end there, we effectively cut it off, and we send the results back to the users saying, well, it didn't drain, you got an error, deal with it. That's not so good. That's not, that's the default position right now. That's how it behaves right now. But application continuity can replay that. So instead of saying, okay, so we've got an error, we didn't drain, let's just fail over the connection, replay it on the wherever the service is now running, and we'll be good. And we turn the results back to the users. The users never see this. Okay. We will replay the database requests from start to finish and guarantee the results coming back are exactly as they should have been when they were first sent to the database. Okay. So that's pretty straightforward. That's how you manage it. Now, for third-party or Java applications, this is an example. Obviously, we have to have the application understand how to talk to the database in terms of replay, in terms of fan events, and so forth. So it knows how to participate in the conversation between the application tier and the database tier to coordinate all this processing. And this is an example of a property sheet from WebSphere. And all we're doing here is we're replacing the jar files. Okay, that's all we're doing. Well, there's a couple more steps. We'll get to those. But this is effectively the most important piece. There's an ONS, the bottom one. That's the Oracle Notification Services. This is the one that transmits the fan events, fast application notification. Those, and most DBAs will know what those are, especially in the rack world. They're events generated from clusterware, dependent upon the state changes within the service that you're using. There are 4 services, service events you're concerned with, or state change events. There's the plan down, planned maintenance, when you're issuing this SRV-CTL, remote relocate service or stop service. It's planned. Okay, the instance or the node you're running on understands this and sends a fan event for that. The next one is an unplanned down or hard down. And that is a fan event generated from another node in the cluster to say, we've lost contact with this node or this instance, and you're out of luck, deal with it. And so your application gets that message and says, oh, well, I have to reconnect elsewhere. So be it. All completely hidden and fully automatic, such that the application does not see it, the users don't see it, and it all happens within seconds and less in many cases. Okay. Third one is start or up. When you introduce a new an instantiation of a start service, or you start in the service, then your application or the connection pool needs to know to connect there. And it's also used for rebalancing, obviously. And lastly, there's in fact, rebalance. When the cluster recognizes there's an imbalance, can send a message up to the connection pool to force it to rebalance. Okay. So these are the 3 jar sets you need. The ONS, obviously I've just discussed. UCP, Universal Connection Pool. So that you're replacing the connection pool that WebSphere itself has, or whichever tool you're using. And then the replay driver. That just replaces the core driver that provided for them for the application. You're replacing it with the replay driver. And obviously replay, application continuity. That's where the logic is built. Okay. Pretty straightforward. You have those 3. Okay. This is we're just talking a bit more, emphasizing the need for fan. It interrupts when your connections are just hung for whatever reason. Okay. Instead of waiting for the TCP/IP timeout, 10 minutes, 30 seconds, whatever, it will interrupt virtually instantaneously, depending on how quickly that fan event is sent out via ONS to registered endpoints. And the registered endpoints are those addresses on the connect string we're using. It all ties together. So this is you automatically configure or register to receive those fan events when you use this connection string. So that's it. You use that connection string, you're configured for fan. It's done. The DBAs, on the other hand, they will still need to open port 6200, which is the one for ONS. It's a one-way trip out from the database on the database servers. But that's it. They have to open up 6200 and possibly on firewalls as well. But it's not a security issue because all the messaging is going out. Okay. FAN for JDBC, there's a few notes here on usage. I think we've covered all this pretty well. Fast connection failover enabled equals true. Set that on the pool, and this is just Java property. So this enables the response to the FAN event. So it receives the FAN event saying we've got a down event, we need to reconnect elsewhere. It'll connect very quickly. So this is the one that triggers the automatic reconnection. And I mentioned port 6200. Unlikely you're going to be using older clients. You should be using the most recent Java or client libraries, the jar files, as possible. They are backwards compatible, they're forwards compatible, but realistically, use the 19C jars and very soon using the 21 jars. They're always backwards compatible and they include all the new fixes and new functionality. And those 19.12 jars will work against a 10 database. That's fine. Okay. Next, and because not all applications use connection pools or understand all this, have the capability to understand it, especially older applications. There's an awful lot of OCI applications out there that are somewhat older, right? Oracle has a few themselves. So instead of doing them understanding fast connection failovers and so forth, we have to initiate draining based on connection tests. Okay. And this is, you have to read this from the bottom up, but essentially we've gone through that process of issuing the srvctl command. That's step one, okay? The database then will mark the sessions to drain, the ones connected to the particular instance and service that we're using. This is exactly the same as what we've seen already. But what is different is there's no pool. And so the application itself doesn't understand what you're talking about, okay? When you say, well, you got to reconnect somewhere else, it has no capacity to take that information. And so what the application needs to do is test its connection before it starts to request. And when it does, the database says, no, you cannot use this connection, use another one. Okay. It's pretty straightforward. It's all in line. These connection tests have been available for, well, remember I think Cy at the beginning said I started in the late 80s, and that's true with Oracle. And we're using SQL forms and so forth, and we were doing connection tests. SQL reports had it, and it still does, okay? Most applications do. We don't recommend doing it on every call, but what we're saying is turn them on so that you're doing them on every as you initiate a new request. Okay. And you can find out what connection tests have been built in, how to enable them. Well, basically, you just have to make sure that the database recognizes them. Okay, and here's the database view of what's being enabled by default. And then make sure you enable them for your particular application or connection pool or whatever. So remember, I was talking previously about, when I spoke previously about a connection pool, it was always an Oracle connection pool. If you're using a native one, you can turn them on there as well, okay? Here's an example for OCI and so forth. Okay. Now here's some of the connection tests built into the current tool sets for mostly the Java space. WebLogic has it automatically enabled. Okay, is usable is another version of is valid. The basic version there is a socket test. Is that socket live and still connecting to the database or to the server and so on and so forth? It is not doing a round trip to the database. cheap, right? And if you increase the level of that, or you can actually do a round trip to the database, but we generally recommend against it. WebSphere, Red, JBoss, and so forth, they have their own versions, and you DBAs will recognize and select one from Dual. It's pretty common, and so on and so forth. Okay. But again, you need to turn these ones on, and that's fairly straightforward. Okay. Getting closer to the end here, where we're talking about some of the new features. This is partially introduced in 19, but fully fledged in 21C. This helps your application to drain properly. Well, listen, deals with applications and or sessions that will not drain, okay, in the anticipated drain timeout. Nothing wrong with that. We just have to replay it. But we thought, let's optimize this. Why, if you've got a query or a transaction you've submitted and the database says there's no way in whatever that you're ever going to drain. You've got a drain time of 30 minutes. This database request is going to take at least 45 minutes to complete, to drain. There's no way this particular statement within this request will drain. So why should I even process it? Let's just migrate it to another node in the cluster, wherever that service is running, and automatically replay it there instead. We're anticipating problems. In other words, we're anticipating the replay, and we'll only do that migration at a place where it can actually replay. It's not going to migrate it and say, oops, can't do it. The database knows all this stuff. It's managing everything. So why not? Okay. It has a number of rules under which it will detect issues and when it will replay and so on and so forth. Okay. Always evolving and very functional. This is, you can anticipate, this is extending support, you might say, for shorter term batch processes or longer running queries and so on and so forth. It improves that functionality coverage. Now, the other point I tried to make earlier is you need to align some timeouts. So remember, what we were talking about is replay and reconnecting. And in the world of, within a rack system with rack failovers and so forth, this is not an issue. It's instantaneous. Users having the replay functionality underneath the covers, handling failures of an instance or planned outages and so forth. They won't see anything. There will not be a blip on the screen. It'll just carry on. But in the case, as I mentioned earlier, of a role transition from a primary to a standby, it takes time. We all know this. If you're probably doing well if you can get this down to 2 minutes and around there. And it's consistency here that's most important. The problem is most of your applications probably have timeouts of 30 seconds. And users in their brains with timeouts probably much shorter, where they say, look, things are not going right. I'll do the Control-C and we'll start all over again. I'm sure something's gone wrong. Well, they have to be educated, obviously. But we also have to make sure that those applications do not time out during the role transition. So if the role transition takes 2 minutes and your application timeouts in 30 seconds, the application reports an error to the users. Well, we've lost all our functionality, you might say. We've not done our job. So this is the last step in this. You need to go back and make sure the application timeouts are increased in the anticipation of role switches or role transitions, whether they're for failovers or for actually switchovers, both cases. We typically don't need to worry about it for rack failovers within the rack cluster. I've never seen that required. Okay. And how long this role transition is important. Obviously, it plays into both the timeouts, but also into that connect stream where you can change the retry count and retry delays. DBA operations, we introduced some new concept in 12.2. This is probably pertinent for, well, anyone coming from 12.1 on previous. This has looked like massively improvement where we actually specify the drain timeout. Defaults to seconds. You can actually set it to centiseconds. I have no idea why. Don't go that short. There's no point.
The stop option, always use immediate. In other words, what this is saying is after the drain timeout, how do we want to stop the instance? These are very much synonymous with the stop options you have when you shut down a database or shut down an instance. Immediate means when your database request completes draining, immediately send the connection back to the pool, and so you can use it. And in other words, by the end, when the last of those sessions is returned to the pool or the application, then we can shut down the instance automatically at that point. Otherwise, we can use transactional, which will actually wait the full 600 seconds in this case. Also introduced with group operations, where we can shut down or relocate services for all the services on a particular node, or all the services connected to a particular instance of the database. And so instead of having to have 100 or 500 different stop on relocate commands all scripted together, you can just use one command or maybe two, and you're done. Okay. Applications are Oracle's applications. This is the way it works, and this is the coverage they have for them currently. Fusion apps, they use WebLogic's mid-tier, so likely you can obviously whatever you can do with WebLogic you can do here as well. Okay, I'm not going to read through this. This is reference material for you. We don't often document this, so if you want to see what it is for different systems provided by Oracle, this is it. And we've got time. We're going to show you a demo. The duck, you guys in the Southern Hemisphere recognize the duck's going the right way, right? Us up in here in the North think it's bonkers, but all the same. Let's run this demo and give you an idea of what we're talking about here. This CAN demo is a good one in that it shows, this is a planned maintenance demo, but it's actually going to show application continuity as well. Up in the far right, the SQL window, you're going to show draining. Okay, it's just a monitor. We do not recommend using SQL Plus for anything but monitoring in this case. It is not a good tool for testing out the application continuity, but that's okay. On the client node there, you're going to see the users, and you're a user, and you're going to see application continuity there. So draining on the top right, client node over here, app continuity, and of course the general workload down at the bottom. Okay. So here we go. We got a user connecting here with SQL Plus. Like I said, we do this just for demo purposes. He doesn't update to one record. Geez, it's fast. Let's get this going again. So he's done one update to one record in his orders table, and then he's gone for lunch. Okay, he did not commit it. That's the key point. Okay, now we're going to work on show you what the status is as in our monitor window to see what's happening. There's this one connection on instance 2. Okay, pretty straightforward. Now we're going to introduce a workload through Swing Bench, and there's a new version of Swing Bench configuration available specifically for testing with app continuity. And if you want that information, I can send it to you as well. It's available through support on Moss Note. Okay, so here we go. We got 40 sessions running a workload. Okay, and now we're going to check status again up in here in the top left to see where the service is actually running. And you notice it's on this instance, the second instance. Okay, so we're going to relocate the service. We're going to move it from instance 2 to instance 1. That's the basic command how to do it. The stop option specified. Now we've specified a 10-second drain timeout. That's very, very short. Don't do that. We only do this for the demo because otherwise we'd be waiting however long. We don't want to be doing that. Okay. And here we go. Notice the workload down the bottom, transactions per second or per minute. Okay. And you'll see here on the top right, the sessions we had were at 41. They're draining. We're down to 15 now. Okay. And they continue down until they hit. Well, now we're looking at connections on instance 1, which is the first one. And then they gradually build up again because new connections being requested and so forth. Notice on the overview at the bottom, there's not been a blip in that transaction per minute window, the graph. Okay. Now let's go back to our guy. He came back from lunch over here, their client, and he realizes he's not committed his transaction. So what does he do? He eventually figures out he's made a mistake and he needs to commit whatever he was doing. And away it goes. No errors. And yeah, so effectively though, he did the update on instance 2, but the commit on instance 1, and no errors were reported to him. Nothing. Pretty straightforward. Okay, it works even for SQL Plus in this case. So what has happened was we relocated the service, reconnected, replayed his transaction to the point that he already was aware of, and then he issued the commit, and everything was fine. Okay, so that's it. Pretty straightforward. Very simplistic, but that's fine. That's what we want with a demo, right? So in essence, we've covered this already in this is a pictorial example of what we've just been discussing. Node 1, Node 2 have a comfortable, the fairly constant load. At some point, we know we're going to be doing maintenance on Node 1, so we initiate a drain. In other words, relocate the service from Node 1 to Node 2 with a particular drain timeout. And you can see at that point that new connections are increasing the load on Node 2, while the old previously submitted sessions and database requests are being drained from Node 1, and so evidenced by the workload decreasing. At some point, we have to terminate that session or that database instance after the drain timeout, whatever length of time that is. And if we had not configured application continuity, we would terminate those in-flight database requests, those sessions, and return errors to the users. If we've got application continuity configured, though, we automatically fail them over, reconnect them to instance 2, where the service is running, and replay them, and return the results back to the users. Okay. Pretty straightforward. Now, we've been talking about planned maintenance so far, and there's not going to be very much here to talk to now for unplanned outages because we've already done all the talking we need. We've covered all the material you need to understand or need to know about. Some backstory here. In 12.1, we introduced application continuity for JDBC Thin. 12.2, we extended that coverage for OCI, the OCI session pool, that is, and ODP.NET. Okay. Then around 18C, we first introduced the early version of transparent application continuity that has matured dramatically for 19 and so on and so forth. Both configurations are fully supported today. You can use either. The one with 12 that we introduced in 12 with application continuity that requires a connection, Oracle connection pool, or explicit boundaries, I should say. Or you can use the transparent application continuity configuration that can support both explicit boundaries and implicit. Okay, and you think, well, why would I ever use the old one if the new one does it just as well? Well, it does, but they function slightly differently in these configurations, and there are cases where you will still want to use the AC one. Not as frequent as you might have been in the past, but certainly if your database is older than 19C, you don't have much choice. Okay. We're not going to run through this demo. Basically, well, let's see. No, we better not. Okay. But what we're trying to get you to do is to, use transparent application continuity. It's available in our cloud by default. You can also switch to the AC configuration if that's what you wish. But to implement all this, you need to understand about request boundaries. We've done that to death. We preserve the session state. So you set failover restore on the database service to do so. Side effects we've not talked about. The side effects are calls external to the database. So you're making a call to an external pragma, util file, and so on and so forth. This is a brief list of these. These are PL SQL pragmas that allow you to write or initiate actions outside the database from within your database request in the database. Side effects may not be important to you. They may, who knows? And this is one of those differences between the two configurations. TAC will not replay them. It's extremely conservative. It has no insight into what you're doing, and it fears writing duplicates or initiating duplicate actions. This is a one-way street with side effects. You don't know what's happened on the other end and whether that's important or not. For the AC configuration, you can enable particular side effects. So hence it's customizable. So if you're writing to a file as a side effect, as a log or an audit trail, or just dumping records from the database to an external file, TAC will not do that as part of the replay, fearing that it's writing duplicates. While the AC one will, and you have to decide whether you're concerned about duplicates or not. Okay. Mutables, that's that fourth row. Mutables are database functions or calls that return different values each time you call them. The obvious ones are, like systime, next val on a sequence. By default, as of 12, these are all fully supported for SQL, but you have to issue grants for PL SQL. The grant is a grant to keep the value, okay? And the reason why we do it for PL SQL is that PL SQL blocks operate under the permissions of the owner rather than the user. So we want to make sure that the grant is made. SQL obviously is just, it's easy. We know that's going to be done. Okay, so this applies to sysdate, systime, next val and sequences and so forth. You do these grants once for PL SQL users and you're done. Again, the point here is when you made your initial request or submitted your database request, you made a call to a sequence and the next val was 47. Okay, when we replay, it better be 47 again. Okay, so we'll insert a constant in place of the sequence call next val and will be 47. Again, guaranteeing that the results you get are exactly as they would have been when you first submitted it. Yeah, pretty important. It has to line up. If we cannot do that, if we cannot make the results exactly the same as they were expected in the original submission, we're not going to replay it. And the replay will fail and you'll get an error messages. Okay, we have to guarantee that. Same goes for if that transaction has been committed. So in case of a failure, what has happened to my transaction? Has it processed? I don't know. So the database, when we go to replay, we'll look and see what's the status of that transaction. If it's already being committed, we'll just return that information and say, well, this is committed, done, move on. We won't replay it, obviously. We don't want to replay it and commit again. So kind of a no-no. Okay. Reset state. This is a new functionality, and I've got a quick slide on that. Let's move on to this. Yes. Okay. Session states we talked about need to be restored completely as part of the in preparation for the replay. Okay. So failover restore needs to be set on your service. If you have complex states, you can use logon triggers, which is very common, or callbacks. Okay. This is support of label security and so on and so forth. Okay, you can use wallets for parameter restores. Okay, we do that in our cloud. Restore, there's a lot of different these PL SQL globals that are automatically restored for you. The ones in green were the ones covered in 12C, and we've extended those. And there's actually a few more pages of these things that are supported for you now. Okay, side effects we've talked about. There's a list there. Mutables. Here's some more information about those mutables. Okay. Reset state. This is a new functionality introduced in 21, and this is particularly for application developers. The whole concept here is if you're using a commonly reusing connections, and this is obviously the connection pool case in most situations, then what happens, you've got the chance or the situation where you're going to run into problems because one user will come along and lease a connection from the pool, do all their work, and when they disconnect or return the connection to the pool, they leave behind all their session state. Temp tables, PL SQL globals, cursor positions, and so forth. And they just sit there, taking up space and resources in the for the session, but also available for the next user that comes along and reuses that connection. So the next user comes along and they've already got state set up for themselves. Now that may be good if that's what you want, if you're using some sort of global session state. But in most cases, it's not what you want. And lazy developers will not clean up the session as they return the session to the pool. They should be. This is one of those areas of well-behaved applications. But if they don't, then the database can clean it up for them. And this is one of those capabilities built into or set as an attribute on the service. So you create a service to configure for TAC, say, and you can assign a reset state of enabled. By default, it's disabled because we have to continue supporting the past behavior by default. But if you enable it, the database will clean up this state for you as the session is returned to the pool. Okay. Lastly, levels of support on protection. This is an AWR extraction. This is available there for statistics. You can notice the user calls and requests and so forth. These lines are in your AWR. I don't know, in this case, everything lines up perfectly. Everything's being replayed or can be replayed. It's protected, in other words. Not always the case. So what happens if those numbers do not line up? Well, then you need to look at the AC check report. This is the old version, still available. It was introduced in 12.1. It is an option on the ORA check report or OREXA check report. -AC check, and this is the way you get what you get. You generated trace files from your particular workload, much like TK-Prof, okay? And you use AC check report as an option on ORA check to report on the exceptions, the failures and warnings. In this case, this is an example run on our Fusion middleware. And if you look through this closely, you can see there's the trace file to which we're referring to, and line 1409 in that first line, first failure. And that's, if you look at that particular trace file, that line, you'll see the call. And here's the error message and why it's being disabled. In this case, it's a side effect. Either we did not enable side effect replays with AC, or it's the TAC application service you're using, in which case they won't replay. So that's the basics. It's still available today, but it's being superseded by this one, AC check utility, standalone utility, the V2, you might say, introduced in 19 and so forth. Well, late 1911, okay, and forward. It's actually a 21C feature. We just backported it because it supports working in the cloud. Remember those trace files? You cannot. Most of the Oracle Cloud implementations do not allow you to access the operating system and the file system. In which case, you're not able to see those trace files. So what we've done is we still get the trace files. That functionality hasn't changed, but we provide database views on top of those trace files to enable you to access and report on the content of those trace files, much like you would any other SQL. There are a couple of canned reports. In this case, you're seeing the full report below. There's a detailed report as well per service, but you can combine the views, the data from the views as you wish. Okay. So this is a good way of finding out exceptions. Remember, the best way is to look at the app continuity as your insurance policy, making sure things are going to work when disaster strikes, you might say. Okay. An AC check is looking for the fine print, the exclusions, you might say. And we all know what that means in terms of insurance. So this is a way of finding out before it happens what is going to be excluded and allowing you to take actions, decide what to do about it. Is it these side effects? Well, is that important or not? So forth. Okay. You can decide and make some changes there. Some cases it may require code changes. Some cases it's just a decision to be made, a reconfiguration, decision to use AC versus TAC, or even TAF. Okay. There's a few more details about configuration for clients. I'm going to zip through this because there's no point in reading. This is reference material. It's in the video now, so you can look back on it. Okay. These are the configuration parameters or attributes on the service to consider. You got auto or transaction. Auto, obviously it's going to be transparent application continuity or application continuity configurations. That's all. Okay. And the reset state and so forth. Okay. We've talked about that already. Replay initiation timeout sets a time period over which we will replay. After that period of time, in this case 600 seconds, we will not even try to replay it. The expectation is there is a timeout, you might say, on the viability of that replay. Because after 600 seconds, in other words, 10 minutes, we think, well, the world's changed. We either shouldn't be replaying or there's no point in even trying because it's going to fail. Things have moved along and we cannot replay safely exactly as it was originally intended. So be it. We've talked about aligning timeouts. That's it. And I'm over time.
Not really. I think this is pretty much like a lot of details. I'm sure people need to go a couple of times this recording. Also, we need to thank Nancy. She basically answered almost 9 questions, but there are 2 questions in the queue. If you can see if we can able to answer.
JMS. Okay, so I'm looking at these ones from Gabriel. Persistent on database accept. Maximum 30 seconds timeout. Okay, so now some of the issues you're going to face here, because this is an older version of WebLogic, are you using Active Grid Link? And if you're not, then limited help we can offer you because there's some issues with the native connections and so forth for WebLogic. So it's best to look at that one in those terms. It's not a simple question of yes or no on how to deal with this. Primarily, you should be using WebLogic's Active Grid Link. Let me look. Reach out to me after the. No, I'll try and reach out to you, and we'll talk about that some more. sheesh. Release of RBS R12. Okay, you got 12.2. App continuity is supported on. Okay, ERP. Yes, 12.1.3. Yes, it does. Now, we don't. It only uses 12.1. Only supports JDBC thin. Okay, so if you've got an OCI application, ERP. Example of that, then you're not going to get support for it. So the point here is, yeah, 12.1 when we first introduced it, it still works beautifully. We've got app customers still running 12.1 with app continuity, and it works fine. But it's only for JDBC thin. Okay, and so that's your problem there, I think. We strongly recommend, and I think you've probably been told already, move to 19C and use the most recent drivers for OCI or Java, and you'd be good. Okay, that's probably the issue there. Yes, yeah, AC check and so forth. No, we see you got to use AC check. We've got two different questions here. One is, can you use async for data guard switchovers or failovers? No. It's active data guard. Use max availability. Okay. In other words, synchronous connections, transmissions. Okay, and the fast sync helps with that, or far sync. But yes, it has to be synchronous. The issue here for us is, in that regard, is that the replay is going to guarantee the results, and that requires the data to be always fully in sync. So if we're working on a transaction and we're missing a key piece of data over on the data guard site, just because of time, then we're kind of in a bad way. So we need to, we cannot deal with the potential of lost data that async introduces in those cases for data guards failovers. AC check can be used. I mean, AC check is just checking the replay capability or replayability of your workload, your individual calls. It has no bearing or no impact, no question about whether it's because you moving role transition or just a rack rolling scenario. So that really doesn't have any bearing there. Okay. Now, if you want to test replay against your switchovers, just make sure the switchover is configured properly. And I would strongly recommend you do so, but it will have to be synchronous. Okay. And there's one other parameter you may be interested in there, and it's actually noted on one of the slides we introduced into the broker, which is the switchover wait. And the switchover there is the actual switchover command in the broker, but we added the capability for wait to say, wait this many seconds to drain the workload from the primary before you do the switchover. Now, some cases you want to do that, in some cases you just want to get on with it. And what we find is, if this is a common, if the switchover is going to take a fair bit of time, and you've got a time limit on that, then you may want to just force the switchover, and then with a weight of 0, and force replay on the other side. But you have to be pretty comfortable about the replayability of your workload to do so. Okay, so I think that's it. Thank you very much for attending. Nancy, thank you very much for answering the questions. I appreciate that. Gabriel, reach out to me and we may be able to address your question in a more fuller detail than we had time for now. I suspect your scenario really is using the wrong connection method. Probably Active Grid Link will fix all that for you as well as it can, if it's available in the older versions. But thanks again, Sai. I appreciate the invite.
Okay, thanks, Ian. Thank you so much. It's a detailed session, definitely, and a lot to digest in terms of details. And also thanks to Nancy and thanks to Anil actually staying behind the scenes and monitoring everything. So guys, also I think thanks to all the participants. It's too late. It's I think it's 9:45 now. So thanks for staying for a long time. And what's coming, it's important as I mentioned, so you need to attend all the sessions. So the next one is coming from Glenn, the evaluation of Data Guard and Active Data Guard 21C features and best practices. So please register, also share with your connections, and see you on Wednesday, 11th of August at 8:30 same time. So with that, thank you again, Ian and Nancy and Anil. Good night for participants and have a nice day for speakers. Bye for now.